Hi comrades, in this video I'm going to be going through the multiple choice questions from the AS Chemistry November test. So, it starts with how many neutrons does the isotope boron 11 have? So, it's told us that it's boron and that its mass number is 11. So what we need to know in order to work out the number of neutrons is what its atomic number is. So we look at the periodic table. So the atomic number for boron is 5. And so from there we can do 11 minus 5 equals 6. This number tells us the number of protons. So the number of neutrons will be 11, the total number of protons and neutrons, minus the number of protons. And that gets us to 6. So the answer to that was B. In question 2, we've got magnesium 2 plus, and it asks how many electrons there are. So again, we look at the periodic table, and we've got magnesium, atomic number, or number of protons, is 12. Overall, it's got a 2 plus ion. So it must have 12 protons, 5, 6, 7, 8, 9, 10, 11, 12. And so in order for it to have a 2 plus charge, there must be 2 more protons than electrons. So I'm going to match up everything but the first 2. And that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it must have 10 electrons. So the answer to 2 is A. 3. Europium has 2 isotopes. One is 153 europium with an abundance of 52.23. What is the other isotope? So, we've got EU 153 and its abundance is 52.53. And then we've got a second isotope that we need to know the mass number for. And we do know if it's only got, saying it's only got 2 isotopes, so the other one must be 47.7. So europium on the periodic table, EU, has a relative atomic mass of 152. So we would find out what this number is by doing 153 times 52.53 plus 47.47 times our x and divide it all by 100. Now we can rearrange all of this to then make x the subject, and if you do that, then x equals 151. So the answer to that is C. A way to quickly see this is if 50% approximately is 153, overall it's 152, then the other 50% has got to be the same distance away on the other side of this 152. If this was 152 up here, then with 50%, the relative atomic mass will probably be 152.5, and so on like that. You can do it just by dividing by 2. So, question 4 is about ammonium sulfate. And ammonium is one of the ions you need to know. It's a single positive, and sulfate is 2 negative. So, with this, we're going to need 2 ammonium for every 1 sulfate. I can't just put a 2 after because it's a polyatomic ion. So I'm going to have to put brackets in and then a 2 after, and then the charge is balanced. So the answer to this is C. NH42SO4. And that just makes that ions on the top charge balance. 5. Which numbers are needed to balance the following equation? C8, H18, plus 11 O2 goes to CO2, CO, and H2O. Okay, so we can just with this, we can put each one in and do it by a process of elimination. 5, 3, 9, we can see if that fits. On the right hand side, we have 8 carbons, 18 hydrogens, and 22 oxygens. Because oxygens are in everything, I'm going to leave that till last to add up. And I'm going to start on this side just by looking at how many hydrogens I've got, which is 18, how many carbons, which is 8, so far it's fitting, and oxygens, I've got 10, 13, 22. So that appears to have balanced straight away from me. You could, just to show you where it doesn't work, if we try the next one, 5, 3, 18. If we just look at hydrogens to begin with, we've got 36 here, 18 times 2, so it can't be B. If we look at C, H is 18. We've got 9, 1, 8. Carbons is 9, so that doesn't fit, 8 and 1, so it can't be C. And then if we look at D, 4, 4, 10, that's got 20 hydrogens, so it can't be D either. So it must be, in this one, A. It's the only one that balances. 6, which number represents the Avogadro constant? So in this, we need to remember 1, the number, and 2, the units. So it's either, in this one, C or D, grams per mole, or moles to the -1, and it will be D. So 6.02 times 10 to the 23 moles to the -1. It's not telling you a mass to the number of moles, it is just the number of particles, so we don't need mass in there. Which is the correct pair, number 7, which is the correct pair of molecular and empirical formulae? So if we go through each one, we've got C4H12 and C2H6. We've got C8H18, C4H8, and C6H12, C3H6, and C4H8, and CH2. So we look at this first one. If the molecular form is C4H12, we need to look at the simplest ratio for these. So although this is a correct ratio, we could have CH3. We could go even simpler, it's a 1 to 3. So it can't be A. B is not the same ratio. It should be C4H9 if it was going to be correct for the empirical formula for this compound. C, we've got a ratio that fits, but it's the wrong ratio. Again, like the top one. No, it should be CH2. For every one of these, we have 2 of these. And then in the final one, then, hopefully this works, we've got C4H8, that's a 1 to 2, and that is a 1 to 2. So it will be D for question 7. Question 8. Brilliant. What is the pressure of 3 moles of gas? So straight away, N equals 3. Volume equals 520 decimeters cubed. Come to that in a bit. Container at standard temperature. So temperature is 25 degrees Celsius. And the gas constant is 8.314. So the first thing I'm just going to look at on this is the units. So it looks like the equation I'm going to use, if we're trying to work out pressure, is PV equals nRT. We need to look at our values first of all. And this is OK value. We need to convert this into meters cubed, so divide it by 1,000. Temperature needs to be in Kelvin. So I'm going to turn that into 298 Kelvin. And then, yeah, gas constant's fine. So if we rearrange this then, we are going to get, I'll put my values in, pressure times 0.520 equals 3 times 298 times 8.314. So rearranging that, if I divide this side by 0.52, times it all out, I'm going to get 14,300 pascals. So A has its 14.3 pascals, that's wrong. B, 1,199 pascals, which doesn't fit. C, 14.3 pascals, kilopascals, is this divided by 1,000, so that fits. And then D, 14,300 kilopascals is wrong, so the answer to there will be C, to 8. Nine, which pair contains a strong acid and a weak base? So 9, we've got ethanoic acid and ammonia. So this is a weak acid and a weak base, but we wanted a strong acid, so that doesn't fit. We've got A, B, same again, ethanoic acid, so a weak acid, and KOH, which is strong base, but we've got the wrong way around there. We want a strong acid and weak base. Can't be A, B or C. C, nitric acid, strong acid, and NH3, we said earlier, that is a weak base. So we've got that one fits. Just check D to make sure. Nitric acid, strong acid. NaOH, though, is a strong base, so it can't be that one. So must be C there. For 9, 10, which statements about oxidation states of chlorine ions are correct? So 1, chlorate is a chlorate-free ion. We'll have a look and check that. So chlorate-free minus, and we've got here, if each oxygen is -2, times that by 3, we've got a -6. Overall, it's got to be a -1, so the chlorate must be a +5. So chlorate is not a chlorate-free ion, it's a chlorate-5 ion. 2, other things, chlorate has a chlorine in a +1 oxidation number, so we can have a look at that again. ClO-, we've got -2 for the oxygen. Overall, it's got to equal -1, so that must be +1. So that fits. So 2 is true. 3, ClO4- has a chlorine in a +7 oxidation state. So we've got -2 for the oxygen, times by 4 is -8. Got to overall equal -1, so it must be +7. So that's true. So 2 and 3 are true, and the answer will be C. Question 11. Just make a note. That's up there, so we're up to. Which of the below is described by a high melting point, can conduct and is soluble in water? So if we go through each of them, aluminium, metal, so it will have a high melting point. It can conduct electricity. It is not soluble in water, luckily for us. Lots of things we have are made out of aluminium. They disappear if it rained. Carbon, high melting point in graphite. It can conduct, but again, not soluble in water. C, CH4, simple covalent compound. Does not have a high melting point. Methane's a gas at room temperature. Can't conduct, not really soluble in water. So not a lot going for it there. D, NaCl. Let's hope this is right. So ionic, high melting point, yep. Can conduct if it's molten, yep. And or dissolved in solution, and is soluble in water. So it is D. So 11 was D. Oh, it did tell you it told you it is sodium chloride aqueous. So that's why it can conduct. It's dissolved in water, soluble. You can see from the first part, and when it is, it'll conduct electricity. Number 12, what is the correctly drawn ammonium ion? So ammonium ion has nitrogen with 4 hydrogens around it. 3 of them are normal covalent bonds, and 1 of them is a dative covalent bond. So we're looking with brackets around, because it's an ion, with a positive charge. So really, we just do it off the brackets. It must be B. But you see with A, we've just got NH3, that's ammonia, not ammonium. So NH3 is ammonia. This is ammonium. It's NH4 plus. So it's B. C is a negative ion, and there's no dative covalent bond. Up here we've got our dative covalent bond. And D is ammonia, but it's lost its lone pair of electrons. Question 13. What is the bond angle of a H3O plus ion? So if we draw out the bonding in H3O plus, we've got oxygen, which has 6 electrons. And if I just do water first of all, we've got covalent bonds to 2 hydrogens, so that's H2O, and ammonium will have a final hydrogen with a dative covalent bond. So if we look at the number of bonded pairs, we've got 3, and if we look at the number of lone pairs, we have 1 around the central oxygen atom. So if it's 3 bond pairs and 1 lone pair, we will have this shape, which is our trigonal pyramidal. And the bond angle in here is 107 degrees. That lone pair reduces it from the tetrahedral by 2.5. So the answer to 13 will be B. 14, which would have the strongest permanent dipoles? Oh, this is a mean question. Right, giving you the data, we've got ClF, CO, HF, or HI. So ClF are very close to each other on the periodic table, one below each other. So they're going to have similar electronegativities. So you'd imagine this would be quite low. CO, not too far off each other. There is a dipole in here, but so I'm going to say just quite high here, but really quite close together, so not that high. HF. H is on the left-hand side of the periodic table, fluorine on the right, so there's a massive difference. This is going to be really high. Now, hydrogen iodine, if we compare H and F, that's going to be high, but that iodine is lower down the periodic table, so it's not going to be as electronegative as the fluorine. So it's going to be quite high, but not as high as the HF, which is hydrofluoric acid. So the answer to this will be C, HF. Fluorine's the most electronegative, so we can probably guess it's going to be one of them. Hydrogen's actually one of the lower, least electronegative atoms, especially for a non-metal. 15 next then, which would have an overall permanent dipole? Well, if we have a look at each of them, we've got water, put the lone pairs on as well, delta negative oxygen, delta positive hydrogen, we've got CO2, which have delta negative oxygens and a delta positive carbon, ammonium, which has delta negative nitrogen with delta positive hydrogens all around, and then CH4, which doesn't have any dipoles. Carbon and hydrogen are too similar electronegativity. Even if they did, they'd all cancel out because the tetrahedral structure is symmetrical, so it can't be either of those, even without CH4 having dipoles in the first place. This is symmetrical. If I drew a line down there, we've got symmetrical, so it can't be that, so it must be this one. So 15 is going to be A, water. (16) We have a look, which molecule has the strongest intermolecular forces? So we've got BF3, which is going to have strong dipole, permanent dipoles. Fluorine, very electronegative, boron, not that electronegative. So, permanent dipole. So the second strongest of the intermolecular forces. H2S. I think they're very, very similar. There's not really even a dipole in there. So I think that's probably London forces. At worst case, permanent dipole, similar to what we had above. Now, ammonium. Oh no, it's not ammonium, it's ammonia. This is one of the 3 that can hydrogen bond. The other one's fluorine, so fluorine can hydrogen bond, but there's no hydrogen here. So we don't get hydrogen bonding there. And H2 is London forces, and very, very weak London forces as that in hydrogen, because there are very few electrons, just 2 electrons there. So the London force is really weak. So this is the strongest one, and 16 will be whichever one had hydrogen bonding. Really, that's a question asking you, what's the strongest intermolecular force? You say hydrogen bonding, and then you just find out which one's hydrogen bonding. So 17, which statement is true? Water's hydrogen bonds, which increase the boiling point. So 1, water does have hydrogen bonds. 2, water is a solid, is more dense than a liquid. That's untrue. So when water freezes, the hydrogen bonds actually hold everything apart and it becomes less dense. That's why ice floats on top of water. That's why your ice cubes float in your drink. So that's wrong. And then water has a bond angle of 180 degrees. We've seen this sort of previously. This is not 180 degrees. In fact, this is 104.5. So 1 is true, 2 and 3 are false. So 17 will be D. And then 18, final one. Which general trend on the periodic table shows a decrease in electronegativity? So they've asked you this the wrong way around. Normally, they'd look for how it increases. So we've got fluorine up in this top right-hand corner. Noble gases don't covalent bonds, so no electronegativity data for them. So it's normally this way. That's an increase in electronegativity. So you need to read the question and see that it shows a decrease, and that'll be down the groups and from left to right. So that is 18 is right to left, top to bottom, B. And that is the multiple choice question.